It's look like a danger one, but nothing. See, given an m by n 2D binary grid which represent a map of one's land, zeros means water. Return the number of right islands. Return the number of islands, right? Normally people will say islands, right? So I'm repeating once again. Given an m by n 2D binary grid, which represent a map of ones means land, zeros means water, return the number of right islands. It is a way of writing, but a way of reading is islands. An island is surrounded by a water is given the definition also. An island is surrounded by a water and is formed by connecting adjacent lands horizontally or vertically. You have assumed all four edges of the grid are surrounded by water. So what you want to say is, listen, what you want to say is one means land, right? One means land. So zero means water. Zero means water. Zero means water. Zero means water. So remember, this is one island. Island is the one surrounded by water. All four sides surrounded by water. So this is one island. You have to return one. Next one. Some people are asking, sir, what about this, sir? Sir, what about this? One here. One here. One here. One here. Right? All the sides, remaining all the side zeros. Remaining all the side zeros. Remaining all the side zeros. So this is one island. See, this is, I think this is the land surrounded by water. This is one island. So this is one island, this is one island. So they are given m by n, one big matrix is given. M by n matrix, right? There may be, it is a one island. It may be one island. It may be one island. You have to identify all islands. Right? So if you write properly, m by n, right? Grid is m by n. See this one? It is a one row. It is a one more row. It is a one more row. It is a one more row. Write in the form of a matrix. So I will write roughly. First one is what? 1, 1, 1. I think it is a 5 row, right? I think 4 rows are there, 5 columns. 1, 0. Next row is 1, 1, 0, 1, 0. Next one is 1, 1, 0, 0, 0. Next one is all zeros. All zeros. Yeah, maybe something is not clear, so I will use another color. Yeah, see this. If you observe clearly in this, I think if you observe, this entire thing is one island. Check once. What is the first one? 4 ones 0. Second one, double 1 0 1 0. Right? Perfect. Third one is 1 1 triple 0. Fourth one is all zeros. Yeah, let's see how many islands are there. So, if you observe clearly, right? Can I say this entire thing is one island? Is it one island? Check. Is it one island? All surrounding, if you see, zeros only there. All surrounding, if you see, zeros only there. Check. And one more thing, all lands are there. Right? All land, one means land. All lands are there, side by side. Right? And one more thing is, for the lands, if you observe, left side, right side, top, bottom, everything, if you see, zeros only there. I think one island. This total is one island. Answer is output is 1. If you want, you can verify. Right? Some people are, what is the island? See the definition. An island is surrounded by a water and is formed by connecting adjacent lands horizontally or vertically. See, it is a horizontal. It is a vertical. So like this. So example 2. See, can you see the example 2 also? Can you see the example 2 also? I'm writing one by one. I'm writing one by one. So 110000. See the second one, 11, right? First one is 111000, right? Second one, if you see 110000, okay. Third one, if you see 00100. Fourth one, if you see 00011. Now, if you observe clearly, if you observe this entire story, how many islands are there? Can you check one time? How many islands are there? Can you check one time? So let me try. Let me try. I think this is one island. This is one island. Right? This is one island. I think this is one island. This is one island. Check. They are not there continuously. So second island and third one, if you observe, they are not there continuously. If anyone says second, third, I will merge, then merge first and second also. So I think three islands. How to solve this problem? It looks so scary. I also initially thought it is so scary. But actually it is a bacha problem. Trust me, it is a bacha problem. So you read problem carefully and remember I am giving the hint also. This can be solved. It is one of the graph problem. I am giving the hint also. It is one of the graph problem. How will you solve this? Let's see. Let's see this. This is one island. This is one more. This is one more. Totally three islands. So in the next class, I am going to give answer for this. I hope you are going to get. Those people who are watching this one, can you write your opinion, your idea in the comment section? And not only watching, people are saying watch after watching is over. Wow, 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 very nice, very nice. Array, very nice. Keep in the comment section. Very nice means how the people got to know. Array, write in the comment section, yeah. Is it nice? Is it really nice? Then keep in the comment section. Na? Why you keep inside brain? It is a very nice, very nice, very nice. If very nice, write in the comment section. And one more thing is, some people are watching and going. Then who will like? Yeah? Who will subscribe? Who will share? Arey, please do, yeah. It will, so that it will reach more people. Right? Number of island. What is the island definition? Also, I explained. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. Right? Next one. What is the meaning of land here? What is the meaning of water here? Remember, in a matrix, 1 means land, 0 means water. An island is surrounded by water and is formed by, right, connecting adjacent lands together, right, horizontally or vertically. So I have so many examples, I can give that also. So I think if you see the first example, I think this is one row. This is one more row. This is one more row. This is one more row. If you write the properly, you will get the clarity. So triple one, right? Let me see some 1, 2, 3, 4, 5. Yeah, I think 5 columns. 11110. Right? 11110. If you want, I will write the matrix format. Next 11010. Next is going to be right, 11100. Next, I think 5 zeros. So this is the matrix given. You have to find out number of islands. Let's check. All adjacent ones. Remember, adjacent, horizontal or vertically, whatever it is. So I think this is one island. Let me know if I am wrong. Please let me know. So output is 1. Number of islands you have to return. See, they all are adjacent. They all are adjacent. Yeah, fine. So in the similar way, second example also you can see. Similarly, second example also you can see. Let's see this one. How many rows? 1, 2, 3, 4. 4 rows are there. How many columns? I think 5 columns. So I will try to adjust here. I will try to adjust here. 1, 2, 3, 4. 4 rows. Columns are 1, 2, 3, 4, 5. Right? So let me write one by one. Let me write one by one. First one, 1110000. 11100. Next one is 11100. Next one also 11100. Okay. Third one is 00100. So last one if you observe, triple zero, 11. 00011. Yeah, you can find out how many islands are there. Can you find out? I think this is one. Adjacent people. All adjacent people you have to take. All adjacent people. Try to remember. Try to remember all adjacent people. This is. See, let me check. Let me check once. So this is one. This is one. So this is one. Check. If anyone having any doubt, 3. Fine. So I think 3 islands. That's fine. Let's go to bigger picture. Let's go to bigger picture. You will get more clarity in this. You will get more clarity. This is one. This is one. Right? This is one. This is the one more one. This is one more one. This is the one more one. Remember, these are not adjacent. These are not adjacent, remember. These are not adjacent, remember. Right? These are not adjacent, remember. Right. You cannot say 2 diagonals taking their adjacent. You cannot say this. So like this, I think how many can you count? 1, 2, 3, 4, 5, 6. 6 islands. 6 islands are there. Right? Be careful, 6 islands. I hope everyone is fine now. Right? Let me go here. I think the answer for this one is, I think if you observe clearly, if you consider it as a graph, the answer for this one is you can apply BFT or DFT. It is something like problem looks so scary. Problem looks so scary, but actually it is the BFT DFT, finding number of connected components. It is one connected component, it's one more connected components, finding number of connected components. Right? But in the case of the graph, if 2 people are adjacent, you will take it. But here, right? So 2 people are surrounded, something like all one, surrounding ones you will take. They surrounding, right? Surrounding vertices, adjacent vertices you will take, but here, right? Surrounding ones you will take. That is the only difference. Simply the answer for this problem is, right? Apply BFT, DFT. So I'm writing here. This problem is similar to. Finding number of connected components in the given graph. and one more to find out the finding number of connected components. For this purpose, you can use BFT also, breadth first traversal, DFT also. You can use any one, whatever you feel you can use. Right? In the graph, two people are adjacent, maybe adjacency matrix, adjacency list they will give. Right? But here in some other way, one matrix is given, right? So adjacent people are ones, adjacent people are ones, group them. If adjacent people are zero, don't group them. Right? That's what it is going on here. Different way of saying it's one of the well-known graph problem. Connecting, right? Finding number of connected components. Right? So I written some small code also. See this one. One matrix I took. I called, right, count islands. I called count islands, right? So when you call the function count islands by sending the matrix, so what that particular one will do is every row, every column, it will scan. Every row, every column, it will scan, right? So whenever it is scanning, I is equal to 0, j is equal to 0. When it is scanning, first it will check. First it will check if it visited or not. If not visited, then it will call DFT algorithm. DFS algorithm it will call. Right? DFS algorithm, it is a DFS algorithm. It will call this. Whenever DFS algorithm is going on, first it has to check. It has to check is it neighbor or not. Adjacent or not, it will check. First it will verify is it adjacent or not. If it's adjacent, and one more thing is marked as, right? If it is adjacent and one more thing, it is not covered. If it is not covered, adjacent and it is not covered. Adjacent also and it is not covered. See. Using this function, using this ESAFE function, I will calculate is it adjacent or not. And one more thing is, I will check is it visited or not. Adjacent and not visited. And once also, if it is adjacent and one, right, then what I will do is I will call DFS algorithm for that. Simply DFS, remember, simply DFS, right? You have to check carefully all the actions, adjacent or not. So adjacent or not, so these are the things which will take. My surrounding people like this. To me, by adding this one, I will get the adjacent people. If at all I am adjacent and not visited, call the DFS algorithm again. Right? So like this, one is already there. One is already there. So next one should I take or not? So adjacent or not will verify. Right? And one more thing, is it one or not verify? One and adjacent called DFS. Right? Next one. Once again, adjacent and one are not verified. Adjacent one are not verified. Adjacent one are not verified. Adjacent one are not verified. Like that, it's keep on going. It's keep on going. So you will group them. Right? You will group them. Then you will count the number of connected components as +1. So every time you will keep on counting. Every time you will keep on counting. Whenever season count is 0 initially. Number of islands are going to be initially 0. After everything, you will increment the count by 1. See, you will increment count by 1. Lastly, return count. That count comes to here, so it will be printed. Some rules and regulations, right? Some rules and regulations. First of all, verify. See this one. Whoever you want to try, first of all, verify. Is he 1? Yes, 1. And one more. Is he not visited? Yes. First of all, whoever you want to go further, you want to count it as an island. First of all, is he 1 or not? Yes. And is he not visited? Yes. Then call DFS. In the DFS algorithm, it will check all neighbors are what? Is it safe or not? What neighbors and all. If at all neighbors, if you find out someone else is not visited, again call DFS. Keep on going like this until zeros will come. Right? So then after completion of total story, count ++. Right? After completion of total story, count ++. Right? It's keep on going for every iteration. Every iteration it will verify. So because of one scanning is going on, right? Order of m and time complexity, order of m rows and n columns. M rows and n columns. Right? That's it. So space complexity is order of mn. Same way. One table required for visiting purpose. Is he visited or not? Because of here mn people are there. mn people are there visiting marker purpose order of mn, order of mn. Simply those people who are not getting BFS, DFS. Please understand BFS, DFS. It is exactly like counting number of connected components. Counting number of connected components.